Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study about the projectiles, topic of projectiles coming under the category of dynamics of engineering mechanics. Let us recapitulate what we have discussed, what we discussed in previous sessions. What is engineering mechanics? Introduction to engineering mechanics. We covered topics like moment of inertia, center of gravity, centroid, and also in previous session also we covered what is some of the equations of motion, linear equations. Now in this session we are going to cover what is the path of projectile. So the terms that are used to describe the projectile motion, there are the various terms are there. Some of the terms are important to describe the path of projectile motion. The motion, the shape of a motion of projectile motion is a parabolic motion. You can see here when we hit the cricket ball, or when we hit a cricket ball with a bat, or when we hit the ball with this various things, the shape, the traveling, the path that traced by a ball to reach the land is parabolic motion, the parabolic path. Now a trajectory is the path of any moving object, that is known as the trajectory. It is the path of any moving object. This is known as the trajectory here for this case. The path traced by a ball or object is known as trajectory. That path is in the shape of parabolic. That's why it's the parabolic motion. Next, what is the term? The term is very important, is known as projectile. A projectile is an object that is given an initial force, then allowed to move freely through space. That is known as a projectile. The next is known as the parabola. What is the parabola? Is the name given to the shape of the curve. A projectile follows when gravity is the only force acting on it. Because of the gravity, it tends to move down because of the initial force. Okay, because of the initial force is given here, the force is given, it has to move some distance here, it has to move like that, it can move like that also. But ultimately it may move like that, finally it comes down, finally it comes. What it is making the parabola shape is the gravity force. That's why when gravity force acts on this object, when it moves, when it is in a trajectory move. Now here, what are the forces on a projectile? What are some of the forces will act on a projectile? Especially there are two forces acts on a freely moving projectile. Number one is air resistance, another one is gravitational force. These are the two forces acts freely on a freely moving projectile. So these two forces acts, it depends upon the shape and density of any object. Okay, and here there are two forces which acts on a projectile, but here when the force is maximum, the magnitude of the force is such a way that it neglects the air resistance. But that means here the gravitational force dominates the air resistance. Now here, this air is depending on the shape and gravity of any object. What will happen? Because of the shape consideration and the density of the object, okay, it is often possible to ignore the one of the force that is known as air resistance. Now this reduces the force on the object to one constant force, is known as in constant direction. That is giving in constant horizontal velocity. Another one is constant vertical acceleration. And here there are two things. One is constant horizontal velocity. Another one is constant vertical acceleration. These two forces, okay, these are the forces, reduces the forces on the object to one constant force in a constant direction. Okay, in a constant direction. The constant direction is in towards the right direction or towards the left. Here, right direction, it may move. But the main force which acts, there are two forces. One is air resistance, another one is gravity force. This air resistance force is negligible in comparison to gravitational force. Now, another one here, the constant horizontal velocity. This horizontal velocity is very simple, and vertical motion can be solved with constant acceleration equations. The equations which we are going to use here, it is constant acceleration equations. If we consider here in this projectile motion, here we can see this is a horizontal motion. The projectile motion is horizontal. Now, whereas the projectile motion, the figure 2, we can see how it is moving. It is moving in a parabolic path. Okay, how it is, we can understand here with the time of different seconds, the time taken to travel from height to down, that is the 20 seconds, and Vx is 100, horizontal velocity is 100 meter per second, and vertical velocity is it is also 100 and 120 when it is reaching down 120. Now here, the projectile motions, it can be horizontal and it can be parabolic, but the path traced by the projectile is here in this figure 2 is a parabolic path. Now, once again, what is the projectile? A projectile is nothing but an object which is projected with some means and continues to move due to its own. This is the projectile motion. Now, the projectile motion, here we are going to study for two-dimensional. There are various dimensional, there are two-dimensional and three-dimensional, but here the projectile motion moves in two-dimensional. Now, what is the two-dimensional motion? Here we can see in this figure, there is a horizontal component and vertical. There are various components are there. Now, there are two components, that is horizontal and vertical. Here, when it is moving, there are two parts are there. If you see two zones in this part, first part and second part. The first part, vertical motion, is upward direction. Here, the object is moving upwards. Whereas, in the second part, the object is moving downwards. That's why the vertical component is acting downwards. Now, if you understand, only one horizontal component remains the same. The horizontal component direction is same in both the two parts. Okay. Now here, the projectile moves in two dimensions. It is therefore has two components, just like a resultant vector. A resultant vector is two components, such as here P and Q. Okay. What is the resultant force? This R equal to under square root of P square plus 2 PQ, P square plus Q square plus 2 PQ cos theta under square root of, there is a term here. Here is similar to resultant force. There are two components here. The resultant vector, one is horizontal vector, horizontal velocity vector, another one is vertical velocity vector. In this case, horizontal velocity vector, it is the direction of the horizontal velocity vector remains the same in both moving upwards, when object is moving upwards and coming downwards. But the resultant, the vertical velocity component is upward direction when the object is moving upwards. When object is coming downwards, it is downward direction. The direction is going to be changed for a vertical velocity component. Now, coming to here, horizontal velocity component. This horizontal velocity component never changes. That's what we cover here. It covers equation equal displacements in equal time periods. This means that initial horizontal velocity equals to the final horizontal velocity. The horizontal velocity remains the same from initial to final. That's what here in this figure, it is moving. The initial horizontal velocity, as I mentioned here, equal time periods it is moving. And the displacement, for equal displacement, equal time periods, here 1 second, for 1 second time period, there is the displacement is 1 meter. Again, same object is moving for the next for 1 second is 1 meter. So what about the direction? The direction remains same from initial to final. Okay, that means the direction of the horizontal velocity component never changes. Coming to second figure, what we have seen in this figure. In this figure here, the horizontal velocity component is constant. Okay, why here? But why? Why horizontal component is constant? Here, the gravity, meaning here, why it is happening here? The gravitational force doesn't act in a horizontal component. That's why it doesn't change. The horizontal velocity is constant. Whereas in the case of vertical component, the direction, the gravity is going to be changed horizontally to decrease the velocity. Here, whereas here, in vertical component, the gravitational force is going to be changed. That's why the direction is changed. Now coming to vertical velocity component. So far we covered horizontal component. Now vertical component. This vertical component changes due to gravity. Now it does not cover this due because of this gravitational force. The way we discussed here for horizontal component, velocity component, it's for equal displacement, equal time periods. But here it is not. Why? Because of the gravity. Now gravity does not cover equal displacement and equal time periods. We can see the object is falling down. For 5 meters, it is 1 second here. From 5 to 20 meters, it is 2 seconds. Again, 2 to 3 seconds, 2 seconds to 3 seconds. The distance traveled by the object is the more time period, that is taking 45 meters. The displacement is 45 meters because of gravitational force. Okay, so in the vertical component of velocity, because of the gravitational force, it changes both the magnitude and direction. As the projectile moves up in the magnitude, projectile moves up, the magnitude decreases and its direction is upward. Here the projectile moves up. What is happening? The arrow here, the vertical velocity is maximum. When it is going high, vertical component is velocity is decreasing. When it is very peak stage, the vertical component is velocity becoming closer to zero. That means why it is becoming the magnitude. Okay, here the gravitational force moving and moving, velocity is decreasing. Now as it moves down, again what will happen to velocity component? Again it increases the magnitude of the vertical velocity component. Here it is zero, it is coming down, increases, and when it is reaches to the land or the surface, it becomes increases. That's what, as it moves down, the magnitude increases, and the direction is downward direction. Okay, as it moves, the projectile moves up, the magnitude decreases, and comes down, magnitude increases. Here the initial stage, the magnitude high, and the final stage, and the magnitude is high. But at the peak stage, the magnitude is low. Now by combining the component, the vertical velocity and horizontal and vertical velocity components, what happened here? Together these components produces what is known as trajectory or the path. This path is what is in shape, which in nature, the shape of the projectile, the trajectory is parabolic. By combining horizontal and vertical, here if you see the horizontal component, the magnitude of the horizontal component doesn't change. Here the magnitude of the vertical component is going to be changed when it is high at the low height and decreases at the peak, and again increases when it is coming down. Okay, so that's what here it decreases. That is a parabolic in nature. So the component, it is the horizontal and vertical, the magnitude and the direction. Here it is the horizontal component. For horizontal component, it is constant, both magnitude and direction, whereas the vertical component, it changes in both magnitude and direction. It changes in magnitude and direction. So that's what the descriptions of vertical components and horizontal components and combining the components. So horizontal component remains a constant, both magnitude and direction, whereas vertical component not remains the same in both in magnitude and direction. Now coming here, horizontally launched projectiles. Here projectiles which have no upward trajectory and no initial vertical velocity. In this, there is no vertical velocity. The horizontal velocity it is 20 meters per second. Now when it travels with the time, the Vx becomes 20 meters per second throughout the horizontal. Whereas the vertical component is going to be changed with respect to the distance traveled, the displacement of the body. Now Vy is 9.8 meters per second. Here the Vy is negative 19.6, 2 times. Again 3 times, you can see 4 times. Or here 29.4, here 39.2, Here finally 49 meter per second velocity component. Now here initial velocity is 0 meter per second at initial stage, and Vx is remains constant. Vox or Vx is constant. Now that is the 20 meter per second is constant throughout, no changing. But here there is a changing, the changing in the vertical component is changing. In summary, the magnitude horizontal component doesn't change, it remains constant both in magnitude and direction, whereas vertical component is changing both magnitude and also directions. But here it is only horizontal component is not vertically throwing. That's why it's the even the downward direction, but the magnitude is getting changed. Now coming to horizontally launched projectiles. To analyze a projectile in 2 dimensions, that's what we analyzed before. We need how many equations? Because Vx and Vy, there are 2 unknowns, we need 2 equations. That's why for 2 dimensions, we require 2 equations are required. One for the x direction and another for the y direction. And for this equation, the kinematic here we use that x is equal to ut plus of at square. What is ut? That is the initial velocity, that is Vox t. What is the s displacement? X equal Vox t plus of times at square. Okay. Now what is that x equal to? That x equal to their component here, x equal to v naught t, and also if you see here, there are 2 components are here in that summation, the displacement, and for of at square, that is x equal to v naught t and y equal to of this a becomes the place of acceleration, that becomes acceleration due to gravity, that is g of gt square. Now here we have to remember that the velocity is constant in horizontal. This is horizontal component and here it is vertical component. Horizontal component doesn't change in both in magnitude and direction, whereas vertical component is going to be changed because of this parameter, that is the acceleration due to gravity, that is a g. So what is that? We have to remember that the velocity is constant horizontally, so that means the acceleration is what? For horizontal velocity, rate of change of, there is no rate of change with the time, there is no change. What about acceleration? The acceleration is 0. Now here, what about acceleration for here? Since the projectile is launched horizontally, for this case, what we studied, then the initial vertical velocity is equal to 0. Okay, initial vertical velocity is equal to 0. Then what is going to be acting here? Only y equal to of times gt square. Now, let us come to discuss about application zone. Now, application part. What we have studied the theoretical descriptions, remember and understands or applied the Bloom's taxonomy components such as remember and understanding. Now, those components we are going to apply here. Unless and until we apply, we can't understand better. Again, we can't remember better also. It's the intercycling. Now here, the point is that we are going to solve the problems. That's the meaning. Let us discuss. We are going to discuss, we are going to solve the problems only for the case of horizontally launched projectiles. Now, a plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. At some point, the pilot drops a bomb on a target below. Number 1, there are 2 objectives A and B. A, how long is the bomb in the air? And object B, how far away from the point above where it was dropped will it land? Now, here there are 2 things. What do I know? What I want to know it. Okay. What do I know? It means what is the given data. What I want to know, that is those are the objective. Here, there are 2 components. What do I know? These are data given. And what I want to know, objectives to be found. Okay. We know that it is here Vox, that the horizontal velocity, that is 100 meters per second. And the distance here, what is the distance y? That is 100 meters is 500 meters above the ground, the vertical 500 meters. And VOY, finally it is VOY, vertical component is 0, and whereas G equal to 9.8 meter per square second, that is meter per second by second. And what to be found? How long is the bomb in the air? How long means what's the time? And how far away from the point above where it was dropped will it land? That is X. We have to find out these two things. Now, the point is that here we know that V equal to of GT square. What is the Y equal to of GT square? What is the Y equal to? That is 500, negative 500 equal to of times G is negative 9.8 T square. From that we can calculate the T. That T is 10.1 seconds. So how long is the bomb in the air? That is 10.1 seconds in the air. Now how far away from the point A above where it was dropped will it land? That is X equal to V naught X T. What is V naught X? 100 times T, 10.1 second. Substitute here. Now here that is 1010 meters. So 10.1 seconds will be in the air, that bomb will be in the air, and from the objective, how long away from the point where it was, okay, it fallen, that is 1010 meters. So this is the problem we solved here. It is related to horizontal launched vehicles category, launched projectiles. Now coming to vertically launched projectiles. Now the component, as we discussed, for this vertically launched projectiles, horizontal doesn't change, horizontal component remains same both in magnitude and direction, whereas vertical decreases up, okay, and it is 0 at the top and increases down, and increases when it comes down, decreases up and it becomes 0 at the top. The magnitude, that is the velocity component, it becomes 0. Decreases, going, decreases, becomes 0 at the top, and coming down increases. And the direction changes, it is in upward direction, and when it comes down, it is downward direction. That's what about the vertically launched projectiles. Okay, that is what decreases on the way, velocity, vertical velocity increases on the way down. Vertical velocity decreases on the way up, upward direction on the way upward direction, and vertical velocity increases again. It is decreases on the way to upward and increases on the way downward direction. So, what is the vertical velocity at the top of the trajectory? What is the vertical velocity? 0 at the top of the trajectory, at this point, at the top, at the peak. After that, it reverse changes the direction. Now, vertically launched projectiles. So far we covered vertical launch. Now, if the projectiles are launched with some angle, so since the projectile were launched at an angle, the vertical must be broken into two components. One is horizontal component, that is VOX. Another one is vertical component, VOY. That is VO is the resultant component. This VO with an angle. This is the same concept we discussed in previous in concepts of engine mechanics, the fundamentals. There is the resultant force with some angle. We have to resolve into two components, that is ROX. Another one is ROY. ROX equal to R cos theta, whereas ROI equal to R sin theta. The same concept here. There are two components, okay? One is vertical component, that's VOI, another one is VOX. That is VOX equal to V naught cos theta. That is V naught cos theta, VOI equal to V naught sin theta. We have to resolve it. Now, in the case of vertically launched projectiles, further we are discussing in here. Now, there are here at the point 0 VOX and VOY. Now it is traveling and VX becomes VOX. Now if you understand the horizontal component, there are two components. One is vertical component, another one is horizontal component. For a horizontal component that remains constant, both the magnitude and direction. Whereas vertical component, it changes, okay, it varies. How it varies? And it decreases when it moves upwards and increases on the way to downwards. That's what the same concepts we are going to apply here. Now, there are several things we must consider when we're doing these types of projectiles business using components. If it begins, yes, okay, displacement is 0. Why displacement is 0 here? The y equal to 0. The point is that there is two component, one Vox and Vo initial stage and angle alpha. The resultant is V0. That Vox equal to V0 cos theta or cos alpha here, Voy equal to V0 sin alpha. Now Vx equal to Vox horizontal. Now same thing, but coming to at the height, the Vy equal to 0, okay, vertical component becomes 0 at the height, okay, and Vx becomes Vox. At this point, Vx equal to Vox, and what about vertical? The vertical component is again increasing. Now finally, when it reaches the ground, Vy becomes Voi in negative direction. Here, initial stage Voi in positive. Here, vertical direction, downward, coming downwards in negative, that is the Vy equal to Voi negative direction. Now Vx remains the same in all places. Vx. So that means the horizontal component doesn't change with the time. Now doesn't change, it remains same, it's constant, both magnitude and direction. Now here the components we studied, x equal to the total displacement equal to V0 xt plus, okay, of gt square there. Now for the same configuration we are going to apply both horizontal and components, and that is called components in the equation. Vox and Voy, we consider x equal to V0 x times t and y equal to V0 y times t plus of gt square. Okay. What is V0 x equal to? That V0 cos theta, Voy equal to V0 sin theta. Okay. This V0 x equal to V0 x equal to V0 cos theta we have to substitute. Then what will happen? That x equal to V0 cos theta times t and y equal to V0 sin theta times t plus of gt square. This is the horizontal and the vertical components. Okay. Now here we are going to solve again. We are going to apply those descriptions or derived expressions, and we are going to solve the problem. Now here, a place kicker kicks a football with a velocity of 20 meters per second and at an angle of 53 degrees. These are what do I know, what I want to know, what we want to know. How long is the ball in the air? How far away does it land? How high does it travel? How long is the ball in the air? That is the time. How far away does it land? That is horizontal component. How high does it travel? That is vertical component. Horizontal B and C, horizontal and vertical components, and A object A component is here. It is how long is the ball in the air, that the time is required. Time, horizontal component and vertical components are going to be calculated. Now V0 is some angle that is 53 degrees. V0 is 20 meters per second. Okay, these two only we know. Okay, how to make it? These are the x component, y vertical, v component, time t is required. We know theta, that theta is 53 degrees, V0 we know. Vox equal to V0 cos theta. What is the V0? 20 times cos 53 degree, that is Vox. Vox equal to V0 cos theta. What is V0? 20 times cos 53. Voy equal to V0 sin theta, that is 20 times sin 53. Okay, now let us substitute as I mentioned here V0 cos theta, that is 20.04 meter per second. Voy equal to V0 sin theta, that component is 15.97 meter per second. Now what I know, what I want to know, as I mentioned here, t, x and y max. What is the y? Y equal to V over t times of gt square. What is the y component at the peak, at the highest, that is 0, y equal to 15.97 times t minus 4.9 t square. From that, t will be calculated. The calculated time t is 3.26 seconds. That is the first objective. How long is the ball in the air? And the second objective, how far away does it land? That is x equal to v naught x times t. V naught x equal to, that is 12.04 times t, that is 3.26, then 39.24 meters. That is the second objective. X equal to v naught x times t, that is 12.04 times 3.26, that is 39.24 meters. That is x. T. What is the third objective? The third objective is that how long does it travel? So a place kicker kicks a football again. So beautifully mentioned here for this. How long does it travel? That y maximum. The y maximum equal to the equation, that is y v over times t of plus of gt square. V over y, that is 15.97 times t, 1.63 minus g is negative here. 4.9, that is g is 9.8 by 2, that is 4.9 times t, 1.63 whole square. That is y is obtained as 13.01 meters. Okay, this is the maximum height, that is 13.01 meters. Now, time, how long? 3.26 seconds. How far? 39.24 meters. How much height? Maximum 13.01 meters. This goes by this consideration. A kicker kicks velocity ball, football of 20 meters per second if he kicks with the angle of 53 degrees. Now it's the question for you to solve as an assignment. Consider 20 meters per second velocity same. Consider this is 45 degree and compare those values with these values and let me know. This 45 degree kicking, if theta is 45 degree and if theta is 53 degree. Okay, what is the time t, x and y max? For which case these values are becoming maximum. Height you can find out y maximum. Okay, and the references are followed in this for this session. These are the references are followed. Okay, and some of the websites and also some textbooks were followed here. That is New Mechanics, that is Principle of Statics and Dynamics by Hibbeler, and Peter Johnston, Vector Mechanics for Engineers. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.